Talk about how to measure the temperature and humidity. And with temperature and humidity sensors, there are many applications we need to read the humidity or temperature. For example, in a greenhouse or maybe at home, we like to know that maybe we need to have the humidifier to make our life a little bit more comfortable. The way we are going to use is this IoT ball, and the IoT ball actually is look like this. So this is our IoT ball. The IoT ball have a microprocessor here and have a temperature and humidity sensor as a buzzer. When the humidity is too high, they can sound alarm for us. And we have a light sensor here and a relay. So after we understand this, how are we going to write programs? First, we blow up our development tool, something like this. The first step is always create a new project. So when we create a new project, we can drag and drop the programming block here to the compilation block. And then we can generate the codes for the compilation block. So it takes a while to open the projects. Okay, so the first thing you want to see is we have a sensor. The sensor can let us to read something into the microprocessor. And if we want to control something, for example, sound alarms, we will go to the actuator. So in this case, first we set the pin 7 as the input pin, like this. And then we read the pin 7, and the temperature was stored in this temp variable, and the relative humidity was stored in humidity. And then we will decide how often we want to measure the temperature by a timer. So this is the timer. So in our situation, for each seconds, we want to read out the temperature and humidity. So we first we configure this once. We set pin 7 as an input pin, and then for each second we read out the temperature. But it's better to print out something and to see if everything is alright. So we use a print block. So we will say that temperature equal, and then drag and drop temperature variable here, and humidity equal, and then drag and drop humidity. And then we put everything, whole things to the compilation block. Just one click on the run block, the code will be generated. And again, click the code block here, and then export Lua file. The Lua file will be sent to the IDE tool. So this is the Lua file. So first set pin 7 as input pin, and then for each seconds, read out the temperature and humidity. Then we print something out. So first we have to connect to our devices by saying connect. So the device will be connected to our PC so that we can download the program to the embedded system. So we can do something like this. So right now the program was sent to the devices. So the devices is here. So if I blow the hot air to the temperature and humidity sensor, it will go up the humidity. So I will do something like this. So you can see that the humidity raised dramatically, and also the temperatures. So in this case, in this way, we read out the humidity and temperature, and maybe within 1 or 2 minutes. So after we have designed the temperature and humidity sensor can be read out from the DHT22s. Right now I'm going to show you how easy it is to connect these IoT devices to the IoT gateway. The IoT gateway right now is a smartphone. So there are two roles. One is it serves as IoT gateway. So many of IoT devices can auto and secure connect to the gateway. The second is it will show the dashboard. So for example, it's temperature, then the temperature and humidity should show up in your smartphones. So let's see how to do it. So the technology is called COAP. COAP is an IoT standard, and which is very easy to implement by using our tool. So the code here actually showing the embedded system versions. So how are we going to make the embedded system into an IoT? First, you have to connect somehow. In our case, use Wi-Fi. So the Wi-Fi devices these devices can use Wi-Fi auto connect to the IoT gateway, which also provide Wi-Fi access points. So the way to do it is we have one block here. So go to the COAP, and then we have auto and secure connections. In this way, you don't need to specify what kinds of SSID and what is the password to connect to the gateways. The second thing is these devices must be an COAP server. So we make these devices become an COAP server. And for a COAP server, you need to register what kinds of service you want to provide. So in our example, we want to provide the temperature information and humidity informations. So we add sensor resources. So here we add sensor resources for temperature. So we register the temperature into this server, and the resources should be temperature. And the second is we add another resources to the server, and this time it is the humidity. So we choose humidity and then register humidity. Then it's done. So we with one single click, the program will be generated here. And again, we can export our IoT programs to the Explorer. So here we have to connect the device again. So let me connect to the device. So right now I connect to the device, and then we can send the programs to execute. So we send to the ESP. So as you can see that the LED expression means it's trying to auto connect to my smartphone here. So once it connect to my smartphone, and then there were new devices will be adding to the gateway. So if I refresh, then you can see that the temperature and the humidity actually showing you your phones. So again, if I hard blow air, then you can see the humidity and temperature will be changed immediately. So let me do it. So you can see that right now the humidity is 99 and the temperature is 28.6. So this is very simple IoT applications. COAP server for temperature. The next we should do is this could be an actuator. For example, if we have LED here, and we may able to turn on or turn off the LED, something like this. So what are we going to do? We need to write an COAP server. So instead of writing the whole code, instead I wrote it up already. Again, you do the auto connection, and then you set up the LED function, and then register it. That's it. And then we can export to the second IoT board. So right now we have a COAP LED server. Then I would connect to the other board. So that connect to the other board and send the code to the IoT board. So you look into the graph here, the video here, you can see that is freshen. That means these IoT devices try to connect to the IoT gateway. So once it's connect to the gateway, then there's a new devices add into the systems, and you refresh it, and you can see that we have an LED light here. So we can turn on. You can see the light is turned on, and turn it off, and then LED is turning off. And we can add many more. For example, we can add a robo car here. So we turn on the robo car, and as you can see that the light is flashing, mean it tries to connect to the gateway. And once it's finished, you can refresh it. And you can see that you can see the control of the remote control car actually is here. So I can and turn the right direction, left direction. Again, I can speed something up.